Okay, I'll go over problem 32 again for those of you who may have struggled with this. Hopefully this will help, but we'll see. Here I have a roll of aluminum. It's been laid out. It expands 32 centimeters long. And what we want to do is we want to take each side and roll it up, or fold it, I should say. On each side we fold it up, and we're going to create a gutter that looks like that. So we start with a total of 32 centimeters long piece of aluminum, and then we'll fold up each side. Now, each side we fold up, we'll call it X. So when we fold it up, we'll be left with 32 minus 2x for the flat surface there. And that's what this picture shows. So we'll have a rectangle. This is a cross section of the gutter. And that cross section will have a width of 32 minus 2x and a height of x. Okay? Now, if you recall, area is equal to base times height. So in this case here, area is equal to 32 minus 2x, that's my base, and my height is x. So, area, in this case here, that's the same as the function c to describe the cross-sectional area. So I'll just replace a with c, so and c will be a function of x. So c of x is equal to 32 minus 2x, that's my base, times my height. Alright, so that's A. B asks us to make a table and graph the function. Well, in order to answer B, we have to find our axis of symmetry. Okay, so we have to find our vertex. Well, our axis of symmetry includes our vertex. So to recall, the axis of symmetry is found by using x equals negative b over 2a. Okay, well, this problem that we have here, the way it's written, it's not in standard form. So we're going to have to write that in standard form to get our a and b. So I need to multiply the equation x, so times each term inside. So this will be 32x minus 2x squared. But again, that's not standard form. The standard form, I would have my x squared term come first. So in standard form, I have negative 2x squared plus 32x. In which case, a is equal to negative 2 and b is equal to 32. So the axis of symmetry will equal negative, so 32 over 2 times negative 2, which will equal negative 30, or which will equal 8 when you take negative 32 and divide it by negative 4. So it equals 8. So that gives me my axis of symmetry. Note again too that this function here, the leading coefficient is negative. Okay, which means I have a sad graph, so it's sloping down. Okay, it will reach a maximum. Well, I found my axis of symmetry. I need to find the y value for my vertex. So I need to substitute 8 for x in the equation. So c of 8 is equal to, I could use the equation negative 2x squared plus 32x. In this case, I just think it's probably a little easier if I just use that equation there. It seems to be a little easier to work with. So c of 8 is equal to 32 minus 2 times 8 times 8. So that will be 32 minus 16 times 8, which will equal 16 times 8, which equals 128. So my vertex is going to be the axis of symmetry 8 and 128. So that will be my vertex. Okay? So there, when we create our table, we always start at our vertex. Oops, it still doesn't quite look like an 8, so let me go ahead and change that again. There we go. So when we create our table, we start at the vertex. So I'll make my xy table. My function c is equal to, and again I'll use this equation for c. Just seems to be a little easier to work with. So c is equal to 32 minus 2x times x. Alright, so we know that when c or x is equal to 8, I get 128. Now we have to go 2 points to the right and 2 points to the left. Alright, so here. So 32 minus 2 times 9 times 9, that will give you, I believe it's 136. So 32 minus 18 times 9, that will give you 126. And then 32 minus 2 times 10 times 10, that will equal 120. Alright, so this being symmetric, then 7 will be 126 and 6 will be 120. Now we can graph our parabola. So let's see here, we said that the axis of symmetry occurred when x is equal to 8, and we get a maximum of, let's see, axis of symmetry is 8, and then the maximum is 128. That's my vertex there. Alright, and then let's see here, here's 9, here's 10, and here's 7 and 6. Okay, so we said at 7 and 9, we get 126. So here's my axis of symmetry right there, my vertex that occurs at 128, and then at 126 I get the point. That's at 7 and 9. Okay, so when x is 7 and x is 9, so 126, 7 and 9. And then at 120, I get the point. That's when x is 6 and 10, so 120, 6 and 10. And there, so there we have our parabola drawn, like that. All right, so that takes care of B. Now C asks us to identify the meaningful domain. Well, you kind of have to look at it like this. We start with a sheet of aluminum that's 32 centimeters wide. Okay, and then we want to fold it up. Okay, and we call that x, and that's 32 minus 2x then, what's left over. So this is x, and 32 minus 2x there. Okay, so what's the smallest x can be? Well, the smallest x can be is 0. That means we just didn't fold it up. Okay, it still remains a sheet, but we're not going to have a gutter at that point. We'll just have a sheet of aluminum. So the smallest x could be is 0. So x has to be greater than or equal to 0. No, what's the largest that x could be? Well, if I fold the sheet in half, it starts at 32 centimeters. 32 centimeters. I can take that sheet here and fold it in half. All right. So this will go up and this will go up. All right, 32 centimeters. But I'm not going to have a gutter. I'll have a sheet of aluminum folded up, but it won't resemble gutter like it does here. All right. Or in other words, this part is not going to exist. I'll just have two sides folded up, like a sheet of paper folded in half. Alright, but what's the maximum? But what's the value of x when that happens? Well, this side will be 16 and that side will be 16. Okay, so x, the largest x could be is 16. And there we go. So that's my meaningful domain. When x is 0, I still just have a sheet of aluminum that hasn't been folded. When x is 16, I have a sheet of aluminum that's been folded in halves, okay? But I don't have a bottom surface like I do here. I don't have a gutter, all right? So that's a meaningful domain. Well, the range, when x is 0, I'll get y is 0. If I go back to the equation, c is equal to 32 minus 2x times x. When x is 0, I'll get y is 0. So y has to be greater than or equal to 0. But what's the maximum y can be? Well, that occurs at my vertex. Okay, y is never going to get any higher than 128. Right? So there you go. Meaningful domain, anywhere from 0 to 16. Meaningful range, anywhere from 0 to 128. So I hope this helps. Let's see here if I've answered all the questions. Find the maximum value of x, that's 8, that maximizes the cross-sectional area. Alright, so 128. So there you go.